Hello guys, hope you're doing well. And as always, if you are new to my channel, I would request you to subscribe to my channel. Thank you. Okay, so the problem at our hand is very interesting, and he is saying to us that if phi equals to 30 and phi is the angle for the F1 and its magnitude is 5 kilonewton and the resultant force is to be directed along the positive y-axis. He says the F1 and F2 resultant, which is Fr, it has to be directed along the positive y-axis. And he says determine the magnitude of the resultant force if F2 is to be a minimum. He says that this F2 has to be a minimum. Then you have to calculate the respective angle as well. Now for this, if you look at it, you know, if you take a triangle, you will always see a triangle hypotenuse will always be greater than, from the length point of view, will always be greater than the perpendicular and the base component. So if F2 is to be a minimum, you can say that it has to make an angle of 90 degrees with the y-axis. And that is what he is also telling you, because when he makes 90, the magnitude will be less, and along the y it will also be lesser than the hypotenuse, which is this one. So that is the reason he says that F2 to be minimum, it must be directed perpendicular to the resultant force, and this is the resultant force along y. It must be directed perpendicular. So theta is coming 90. Half the problem is solved. Now he also says that determine the magnitude if F2 is to be a minimum. So we have made it minimum when it is acting along this direction. So if I draw the free body diagram of this system, you can very easily see that this was our 5 kilonewton force, okay, and our Fr is acting along the y-axis. As he has said, it has to act along the y-axis, but this F2 has to be making an angle of 90 degrees with the y-axis, as we have shown it here, because of the minimum factor. So you can see in this problem, this F2 is making an angle of 90 degrees with Fr. So if that is done, so now our parallelogram is formed. Now we can very easily, according to the conditions, we can take out one triangle. Say we take out this triangle, and we put it here. So this is our F1, this is our F1, this is our Fr, this is our Fr, and as this is our F2, see the vector ending here, the arrow ending here, so the arrow has to be end here also. So this is F2. So you can see that F2 is making an angle, this is your Fr, making an angle of 90 degrees with Fr. Condition is being done. The angle between F1 and Fr is 30 degrees, and if you look at it, the angle between F1 and Fr is to be, you can see the angle between F1 and Fr is 30 degrees, and that condition is still being approved. The angle between F1 and Fr is 30 degrees. Now you look at it, simply you can solve it from this simple triangle. So what will be going to be F2? If this is 5 kilonewton, so F2 will be 5 sine 30. F2 will be 5 sine 30. What will be Fr? If this is 5 kilonewton, so Fr is equals to 5 cos 30, which is 4.33 kilonewton. One unique thing, if you look at this problem, you see that Fr magnitude is basically coming as 4.33 kilonewton, even though it is a resultant. But the force F1 is 5 kilonewton, which is more than Fr. So because we have made changes, we have made many changes in this problem. They have said something different because of the minimum factor and all that conditions being done. So the condition has changed slightly. So it was a very good problem and quite interesting. I hope this problem helps. You have a wonderful day.